Hello, and welcome to another exciting edition of Pandemic Radio. I'll be your host for today's episode, Dr. Brett Bales. And today I want to talk about planetary health and give you a really brief introduction and a broad overview of this exciting, emerging, very important field to hopefully get us uh, prepared for our upcoming discussions on the origins of COVID 19. So sit back, relax, crack open a cold LaCroix, Mingo, yum, and let's get started. So I want to introduce you to our friend, the loneliest tree in the world. And if you're confused, that's okay. We're going to come back to that. But first, a quick history lesson. So, you guys have all probably seen something like this in one of your science classes over the years, and it's a kind of brief history of life on Earth from really simple organisms all the way up to where we are now. And these long time periods are not measured in months or days, they're measured in geological periods or epochs. And they are characterized by the types of plants and animals that were around during that time. So, you guys have all probably heard of the Jurassic period, and the Jurassic period is characterized by certain types of plants and animals that were around during that time. And a lot of these periods are quite long and do experience kind of natural fluctuations. Plants and animals come and go. The environment and climate shifts over time. And, we can note that and mark that with these changes in geological time. What's important to consider here is where humans are. We are in a tiny little sliver called the Holocene epoch. And when you compare it to the rest of life on Earth, we have been around for what's a cool way of saying this, hot minute. And during that time, uh, we've made quite an impact. And when we measure these, you know, large periods of time, we're basically measuring the impact of whatever was on the planet at that time. So the reason why layers of rock or layers of the Grand Canyon look different is because there were different types of plants and animals around during that time. And if you dig down, you're basically looking back in time. And you can see distinct changes in the biological record. Certain types of plants and animals are characterized by these layers, and we give them names: Jurassic, Triassic, etc. Human development during our little sliver of time, the Holocene epoch, has been pretty extraordinary. Here's an example. For those of you who don't know, this is Elon Musk. He is a rather interesting fellow who is very, very rich, owns a rocket ship company, SpaceX. He owns a car company, Tesla, and recently he used his rocket company to fly his car into space. This is a real photo. This is not doctored. It looks fake, but it's real. He launched his Tesla Roadster into space to test out one of his latest rockets. And the point of all this is, one, it makes for a pretty cool slide, and I'm kind of a space geek, but it really, I think, illustrates the dramatic development that humans have undergone in that relatively short period of time we've been around. So we've gone from uh, hunter gatherers roaming around and hunting and eating whatever we could to settling down and planting crops, forming cities, etc., up to launching cars into space. And this progress, this development has consequences that define and change the environment and the planet during this time. So the rapid increase in car use has led to a rapid increase in greenhouse gas emissions, for example. Other examples are how we use land. So this is a map of all the places on the planet that we use to grow uh, crops, food, and one thing to note is we're kind of using up all the good land. That is to say, all the land that can be farmed, a lot of it is. So you notice the kind of bare spots in, you know, parts of northern Africa, which is all desert. Everything up in the Arctic. Um, we're using a lot of the land that can be used to feed a growing human population. A lot of the fresh water that is available is being used. A lot of it for crops. We are exploiting uh, fisheries beyond sustainable limits. So 90% of fish populations are being overfished. Deforestation continues to be a major issue in many parts of the world. We have um, cleared forests from many parts of the world. And as we'll see when we get into our discussion of the origins of COVID 19, this can be a pretty big problem when it comes to diseases. So, a little foreshadowing there. A lot of the rivers on the planet have been dammed to aid in agriculture and energy, hydroelectric energy. And one that always gets me right in the feelings is the loss of mammals, fish, birds, reptiles. These populations have been cut in half in the last 45 years due to human caused extinction events. This is one of two northern white rhinos left on the planet. Both of them are females past breeding age, so this is a functionally extinct creature that requires 24-hour park ranger guard and is a kind of sharp contrast to the good news, which is humans are healthier on average than they've ever been. Uh, there are still health inequities and there are still gaps in access to healthcare and poverty, but on average, human populations are doing a lot better than we kind of ever have been. So life expectancy continues to increase, poverty rates decreasing, child mortality rates decreasing. We're doing well overall, but ecological degradation continues to increase. So, how could that be that our health improves while the health of ecological systems goes down? Dr. Bales, I thought you were inferring that we needed the environment for our health. How can that be? Well, this is a paradox. This is the ecological paradox, which is basically these two things are going in opposite directions. The health of the planet is going down while the health of people are going up. And a way of looking at this is essentially we're borrowing from future generations. We are mortgaging the health of future human populations to realize short term gains. So we are exploiting global fisheries. We are utilizing forest resources for short term economic benefits and human health benefits. But if it's not sustainable, that means it cannot continue indefinitely, and that resource will not be available in the same way in the future. And we really started to focus on this when we started exploring outer space more. And this was one of the first images taken of the Earth from outside the Earth by an early NASA astronaut who said, "We came all this way to explore the moon, and the most important thing is that we discovered the Earth." And I take that to mean, if you look at the Earth, it's this beautiful little kind of blue marble of life in this big, bleak, empty, expansive space next to this uh, kind of ice, desolate, dead foreground of the Earth. Um, we live on a kind of special, fragile, finite space. The resources that we see being kind of exploited or degraded, uh, not infinite. And we can measure that in a lot of different ways. So we can look at how socioeconomic trends are rapidly changing over the past, let's say, since 1950-ish. Things like population growth, uh, water use, fertilizer consumption, all of these kind of socioeconomic indicators are rapidly increasing. And at the same time, all of these indicators of how basically the planet is doing are also rapidly changing. So the amount of carbon dioxide in the atmosphere, the amount of tropical forest that has been lost, um, ocean acidification, all rapidly increasing over the past, let's say, 50 to 60 years. And if you look at these two uh, sets of trends, you see a really strong correlation and relationship. This rapid increase, this rapid change over the past 50 to 60 years is what's known as the Great Acceleration. And geologists, archaeologists, scientists in the future will be able to look back and see evidence of this great acceleration in our fossils, in our imprint on the planet. And they'll look at things like technofossils, so stuff that's going to be around for a really long time. Plastics, radiation from atomic bomb testing, large scale extinction events. So they're going to see, evidence of a lot of different types of animal bones. And then it's going to start narrowing down really quickly to just a few types of animal bones. And they're going to start scratching their heads and wondering if our planet was overrun by chickens at some point because they're going to see so many chicken bones. And the name that is given to this rapid change uh, is the Anthropocene. And this is actually the name of the new geological time period that we have entered into. Our little sliver, the Holocene, we're done with that already. We're into a new time period that is characterized by the human kind of dominance or footprint on the planet, that we have changed the planet to such an extent through the Great Acceleration that we have actually bumped ourselves into a new geological time period, the Anthropocene. And so, when did this kind of begin? When did we make that shift from the Holocene to the Anthropocene? Uh, well, in some ways, it's kind of an arbitrary question, but an interesting one. And some people think that it's when we started farming. Some people think it's when we entered the Industrial Revolution, and others say it's when we started testing bombs, the nuclear bombs that sent us into the nuclear age. Let's say, for the sake of argument, that it's when we entered the nuclear age, when we started testing the atomic bombs in the middle of the 1900s. This is an atomic bomb test in the southwest of the United States, I believe Nevada, um, and it shows this really huge bomb, and up in the mushroom cloud is a bunch of dust and debris and stuff that got blown up by the bomb, and also all these little radioactive particles that will now go up into the atmosphere and start spreading around. And one thing about these little radioactive particles, they're not like snowflakes. They don't just kind of melt or go away. They stick around for a very, very long time. And this brings us to our lonely little tree. Our lonely little tree lives on this lonely little island off the coast of New Zealand in a really isolated part of the world. And when researchers paid our little tree a visit, um, and ever so delicately drilled a uh, borehole into the trunk to get a sample, not to kill it, uh, they noticed something interesting in its tree rings. They noticed a little sliver of radioactive material, which is when that radioactive material from that atomic bomb test that entered the atmosphere made its way all the way around the world, landed on our little tree in the middle of nowhere, and got absorbed. And this happened on October of 1965, and it really demonstrates that in this super far removed, remote part of the world, even here we can see evidence of human activity. So there's really no place left on the planet that has been untouched by humans. And some argue that this could be the beginning of the Anthropocene. And with this new geological time period comes a new field of research that we have changed the planet to such an extent that we actually need a new way of researching what the effects of this are. And this new way of researching and thinking about this has been called planetary health. And I consider myself a planetary health scientist, and I'm a strong advocate for planetary health science as a super useful tool in not only understanding how human health and environmental health are related, but for impacting policy decisions, um, and for getting more disciplines than just like public health or just ecology interested in this problem. This is for nurses and doctors and PA as much as it is for ecologists and biologists. Uh, this is a framework and a field that brings a lot of different types of expertise together. Because as we'll go into, the the issues that we're dealing with here are pretty complicated, and it's bigger than just one discipline. So this is bigger than public health. This is bigger than ecology. This is planetary health. So what in the heck is it? Well, I mentioned that it's an effective policy tool. So we've all seen the sad pictures of that polar bear clutching the last little bit of ice because of climate change. Um, we can all agree that losing trees is bad because trees are good. They're pretty. We like to go for hikes. When it's hot and sunny, we sure do appreciate a tree to sit under and read a book. Um, but it's difficult to bring this kind of argument to a policymaker who is tasked with deciding whether we should protect a forest or um, whether to cut the forest down for some kind of economic project. Uh, it's not a super powerful argument to go to this policymaker and say, you cannot cut down this forest because it's going to make the polar bear sad and it's going to make the trees sad. Um, that's not a powerful argument. It may be true, but I don't think it's going to affect change in the same way that, hey, if you cut these trees down, here's how that's going to affect human health. Here's how it's going to affect um, the economy. Essentially, seeking answers to this question: how do changes to the environment make us sick? Um, and in addition, how do changes to the environment basically affect our health? That is really at the core of planetary health. And changes to the environment can affect health in many different ways. And this is an exciting emerging field, and we're just starting to scratch the surface of understanding how environmental change impacts human health. And it does so in a lot of different ways: mental health, chronic diseases. Um, but because this is a COVID-19 class and you guys came for the COVID, we're going to now start to focus more on how these changes to the environment impact a subset of disease called emerging infectious diseases. So, infectious disease is not a new thing. Infectious diseases they've been around for human history, and in the United States they used to be a really big problem. But then in the mid 1900s, good vaccines were developed, and mortality rates of a lot of infectious diseases really plummeted. And this was all really good news. And even the Surgeon General at the time said, hey, we did it. We won. We wiped out infectious diseases. We don't have to worry about infectious diseases anymore. But then along comes HIV/AIDS. This is the first case report published by the CDC in 1981 of a group of young men with an odd form of pneumonia. This signals the start of the HIV epidemic in the United States. And in the decades to follow, it's a lot more than just HIV/AIDS. We start to see these kind of headlines. And look on any news screen, look on any news website. What are you going to add to this list? COVID. And in addition, turns out a lot of other things that maybe aren't so newsworthy, but are happening. Over 300 infectious pathogens in the past 50 years have been discovered in places they never have been before. So we got some household names on this list, but there are many others. So there's the Ebola, H1N1 2009, etc. So these are a class of human health uh, diseases called emerging infectious diseases, meaning they are new kids on the block. So why is this happening? If you've ever taken an epidemiology class, or maybe you're just curious, well, why? It looked like we were doing so good. We had, I thought, won the war against infectious diseases. What happened? Well, to understand what happened, we need to understand the kind of basic, fundamental uh, epidemiological principle of infectious disease transmission. And that can be really simply summarized with the epidemiology disease triangle. So, for a disease to occur, for a case of malaria or case of Lyme disease or a case of COVID, to occur and to be counted and to go into a data set, these three basic elements need to exist. Obviously, you need to have an infectious agent. You need some virus or bacteria to cause the disease. You need a susceptible person to, get sick to be counted as a disease. And you need an environment that allows them to come together. Okay. So, uh, this is what we're going to focus on in this class. And this is what planetary health helps us to understand, that it is because of changes to the environment that allows a lot of these new infectious diseases to occur. And a lot of that is because maybe before this environmental condition was not suitable for the pathogen and the host to come together. For example, maybe there wasn't malaria in a certain part of Central America because it wasn't warm enough. Or maybe it rained too much or not enough. It turns out mosquitoes that transmit malaria are pretty picky, and they like certain types of environment. Not too hot, not too cold. They like a certain amount of rain. If the climate changes to where now all of a sudden the environment that wasn't such a great place for mosquitoes now becomes a really happy place for mosquitoes, now this triangle has been complete and you have disease. And changes to the environment can occur in a lot of different ways, not just climate change, but things like deforestation, loss of wildlife, etc. There are a number of different ways, and we're learning about new ways all the time. Some of them are surprising. And again, that is why I think planetary health is such an interesting field of study, because we are constantly faced with surprising circumstances. And part of being a good planetary health scholar is expecting unintended consequences and surprises. So it's shifting our thinking to really like what's causing the malaria or the West Nile virus or the Zika or the COVID. Um, how could that or how does that relate to changing environmental conditions? So one big environmental change that I just talked about is climate change, or some call it global warming, where the planet's temperatures are increasing. Well, it turns out that mosquitoes get hungrier when it's hotter. It increases their metabolism, so they go through their food supplies faster, and they need to eat more, and so that makes them bite more. And when mosquitoes are hungrier and biting more, they are increasing the risk of malaria and a lot of other infectious diseases. And maybe some parts are the environment's not right. Maybe it's too cold and mosquitoes don't like to live there. So, with a changing climate, with a climate that's getting warmer, now all of a sudden, areas that were too cold, maybe now they're just right. And that triangle is now complete. So now you have all the elements necessary for disease to occur. This is an example of West Nile virus in North America. Areas in red are where that triangle is projected to be complete because of changing climate. And this is something that, for example, a nurse should know and should be equipped to understand, because let's say you're a nurse in Vancouver and you go to you get all your clinical training, you learn about a lot of the diseases you'll probably be faced with in your community. And when someone says, "Hey, uh, we're going to learn about West Nile virus," you say, "Well, no, that's not around here. That doesn't exist here. I don't need to worry about it." Um, According to this is going to be a kind of growing threat in that area because of a changing environment. And planetary health allows us to anticipate this and to begin preparing and maybe even preventing. There are a lot of ethical considerations within this field of planetary health, and uh, a lot of that has to do with the fact that these changing environmental conditions um, impact some people more than others. So, not everyone or not every group causes changes to the environment equally, and not every group feels the effects of those changes equally. This leads to a new way of thinking about the ethics of environment and health in a way that uh, is well suited to occur within the field of planetary health. So, policy decisions, individual decisions that are made and that affect natural systems. So, for example, a decision on whether to replace a forest with a pasture to grow more, or to either grow more crops or to have more cattle for food. Uh, that is a ethical decision that not only affects that location, but if it can be shown that that change in the environment is going to increase climate change, is going to increase the rate of malaria or Zika, um, that now affects more people than just that forest area. Um, it's individual decisions. So, dietary choices, the way that we move around, our transportation choices, a lot of different individual decisions, all the way up to country level policy decisions that affect natural systems, fall into this kind of new ethical terrain. And I compare it to this example. So, smoking is an individual decision, technically. Uh, I think that it's important that everyone is properly educated on the risks of smoking. But ultimately, when someone chooses to smoke or not, that is more of an individual decision. But when that smoking now occurs in like a airplane or a restaurant, that individual decision now has public health consequences. It now affects other people. So that's why you see things like smoking in airplanes and restaurants banned, because it is an individual decision that has a collective impact. So, is that the same thing as whether you choose to purchase a Prius or a giant gas guzzler? And if the evidence suggests that uh, cars that produce more greenhouse gases can increase climate change, and if climate change impacts human health globally, is this an individual decision of what car to buy? Or is it now entering into that realm of smoking in a restaurant? And I'm not here to provide an answer, but rather to show you that this is an example of the kind of ethical debate that occurs in the field of planetary health. So this planetary health approach, this relatively new discipline, um, is also a call to think more broadly than traditional medical science is used to. So, clinical medicine, when you go to medical school or when you are training to become a nurse, A lot of clinical medicine is focused on systems within the human body and with ways to treat individual disease. Planetary health is really focused on broadening this perspective to all the external systems um, that threaten health. So, I think another way of saying that is that we have to uh, look beyond things like vaccinations, um, quarantine campaigns. Um, these quote, according to this article, just kind of scratch the surface. Um, if we want to have effective solutions, we really have to address the whole system, okay, and the underlying kind of ecosystems. And planetary health is a field that allows us to do that. Okay, it is. It's like looking at a doctor in a clinic that is treating a lot of patients with diabetes. And maybe this doctor treats the same type of patient with diabetes, provides medication, treatment plans, and then more patients come in with diabetes. And the same thing, you try to provide them with treatment, send them home. Um, that is a cycle that's going to continue unless you understand what the external systems of the environment, the social and the physical environment are that are increasing diabetes in this community. So it's really looking at like the root cause of the problem rather than just trying to treat the end result. And that's what planetary health seeks to do. And it's looking at upstream solutions rather than just downstream problems. So it is looking at, let's say, another example is, like a wildfire. Uh, you want to really understand like what's causing the fire to spread, rather than just running around and trying to put out the little kind of spot fires. Uh, you want to understand not just how to treat the patient with diabetes, but what is happening upstream in the community that is increasing the amount of diabetes. So, is there something in the social environment that is, or physical environment that's doing that? And it's really the shift away from what's called tertiary prevention, which is treating disease after it's already occurred, to preventing disease from occurring in the first place. And this is really where public health comes into play. And planetary health is really, I really like this quote. It's a way of kind of looking at like public health in a new way. It's been referred to as public health 2.0 because, as this says, public health alone can only take us so far in addressing today's complex health challenges like COVID 19. We need this new interdisciplinary field um, for our new reality. And that is planetary health, which is another way of saying kind of like a reboot of public health. Um, and really, what that means is we have to stop just focusing on human health, and we have to start treating human health and the health of the planet as kind of one system. So they are linked, and we cannot have sustainable health without sustainable health of the planet. So I'm going to end with a little kind of inspiration. So this is Carl Sagan. He is, I guess, he's like the original Neil deGrasse Tyson. He is like a Bill Nye, but he's like the original, and he's a brilliant astronomer, cosmologist, scientist, and he's a really good science communicator. Um, he's awesome. Carl Sagan. Look him up if you haven't heard him. It's great. And he had a really important role in developing this spaceship. We're back to outer space. But hey, planetary health, get it? Okay. This is the Voyager spaceship. And Carl Sagan was involved in this project. And basically, the Voyager spaceship, it's a satellite of sorts, was shot out into deep space. This didn't just go out and circle around the Earth or go out to like Mars. This went out deep out into the solar system and beyond. And Carl Sagan thought it would be, I think, kind of a fun idea to put some information on this spacecraft about Earth. So, kind of like a message in a bottle. So, you're sending this thing out, never to return, out on a one way ticket to the deep reaches of space. Um, why not include a little bit of information on the Earth just in case? So, on it is a gold record that contains a lot of information about the planet. So, uh, different languages. It has a human heartbeat on it, and some kind of information about the planet. And this spaceship had a twin, Voyager 1 and Voyager 2, and they have recently left the solar system. They are far out into deep space, into what's called interstellar space. So you can see all the planets in our solar system. Oh, look, no Pluto. But it's traveling at a astonishing speed. So these little spaceships are traveling at 11 miles per second, and that's not a typo. 11 miles per second. And I think we should just kind of take a moment to remember Pluto, RIP. But the Voyager, the last thing that it did before it left the solar system and before it was too far out was it turned around and it took one last picture of Earth, where it came from. And remember, this thing is traveling at 11 miles per second, faster than a bullet through space. And that's the Earth. That's it. Um, and that little speck is the Earth. And this kind of colorful line that it seems to be caught in is a sunbeam that just happens to be hitting the Earth um, at that time. So Carl Sagan looked at this photo and he said the following: a mote of dust suspended in a sunbeam. If you look at it, you see a dot. That's here. That's home. That's us. On it, everyone you have ever heard of, every human being who has ever lived out their lives. Our planet is a lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. It is up to us. To me, it underscores our responsibility to deal more kindly and compassionately with one another and to preserve and cherish that pale blue dot, the only home we have ever known. And to me, that is planetary health. And that is, I think, the mindset and the approach that is important to take to heart as we begin now to explore COVID-19, which is an emerging infectious disease uh, that we are going to study through the lens of planetary health. So that's it for our fun. That's planetary health in a nutshell. There are lots of fun readings on the website. I suggest you look through at your convenience. And be on the lookout for more exciting hashtag content on Pandemic Radio. See you guys on the flip side.